Oh, right. No, bad.
Oh, and incidentally, if you want to do a word problem or two, I've got plenty on my computer, so we can save 5 or 10 minutes if you'd like. I'd like to do a better word problem than the one you gave me, which really kind of sucked as a word problem, if you want my honest opinion. But,
yeah, it gave the variables and pictures for starters, so.
Well, right. And it was just way harder than it needs to be. If you were teaching somebody how to do word problems, you would not start with that one, the one you gave me. So
I have a kind of a basic equation here just to get back in the rhythm of things.
Okay, go ahead.
It is 17 over 2x plus 7 over 5 equals 3 over 2x.
Okay. We could do this the hard way, which would be to add this fraction to this fraction. But there's actually a much easier way to do this problem. I have a 17 over 2x over here, and I have a 3 over 2x over there. I can combine those terms. They're like terms.
So make 20 over 2x.
Not 20. If we're going to move this to the left side, I have to subtract it.
Wait, but then we wouldn't know if it's equal to the answer though, right?
Well, here's what I'm going to do. I'm going to subtract 3 over 2x from both sides. Minus 3 over 2x. Okay? That leaves 0 on the right. What does it leave on the left? Well, I can combine those. I have 17 over 2x minus 3 over 2x. That's 14 over 2x.
Right.
Which actually simplifies to 7 over x. You see that?
Mm-hmm.
Still have the plus 7/5. So now I'm going to move the 7/5 to the right side of the equation because it's a number. So now I have 7 over x equals minus 7/5. Now what does x have to be?
Why did you move the 7/5 over to the right?
Because it's a number. When you're solving an algebra equation, you want to get all your variables on one side, all your numbers on another.
But you were supposed to add it to the...
No, we didn't need to do it. We didn't need to find a least common denominator and add those two together. That wouldn't solve for x, by the way. Whereas doing it this way is going to allow us to solve for x. Because all I did was I put the number on the right side of the equation and left the variable on the left.
Oh, okay, we're solving for x. And for some reason I thought we were trying to make it equal to the 3 over 2x that we had in their beginning.
No. Don't need to.
Okay.
In other words, we combined like terms by moving the 3 over 2x to the left side.
Right.
And we're going to move the number to the right side. So we end up with this. How do we solve this for x?
We can cross multiply because they're two proportions, correct?
Correct. They're two fractions. Whenever you have two fractions equal to one another, you can cross multiply. And now x is going to be equal to minus 5. 35 divided by minus 7.
Okay, I see that.
Okay. All right. What else you got?
Let's see. That one we just did.
Now, notice that one that we just did, I could have done it a much more difficult way if had I not done it the way I did it. In other words, I could have started out this whole plan to go ahead and find a common denominator and combine those two things, and then cross multiply and solve for x. But that would have been harder, because then I would have had to find a least common denominator to add these two things together.
Right, and it was just right there from the beginning.
Exactly, because this was 3 over 2x, that's the same kind of thing as this is, and I can combine those two, put the number on the other side, and I'm basically done. So I don't have to go through the arduous process of adding two fractions that don't have the same denominator.
But you had to see that you could combine like terms.
Right. I noticed that this had a denominator of 2x, this has a denominator of 2x. Had that been like 5x, then I couldn't have done it. Then I would have gone ahead and done it the normal way.
I have one word problem here.
Okay.
So it's talking about a gas pump. One pump fills up a tank 2 times as fast as another pump.
Okay.
If the pumps work together, they fill the tank in 8 minutes.
Okay.
How long does it take for the faster pump to fill the tank?
Okay. Well, they don't give you easy problems. This is technically a work problem. It's a word problem, but it's also a work problem. Okay.
Right.
So we have pump 1, the fast pump. And we have pump 2, half as fast. And together they take 8 minutes. Thinking for a moment. I'm trying to remember. It's been a long time since I got in a work problem. Work problem, there's always a way to do it that is an easy way. I'm trying to remember what it is.
So can't we take, let's see, pump 1 and just set up an equation for 1 equals 2 times minus, or, oh. Part of me wants to do this in my head and just say take half of it.
It's easy to do that, to want to do it in your head. Unfortunately, if you did and say this takes, well, yeah, hold on a second. Let me think for just a minute. I'm tempted to say 12 minutes. Yeah, let's see. Let's do this in reverse for just a minute, just so you can understand how to do it. Let's say pump 1 takes 12 minutes to fill it up.
Mm-hmm.
Pump 2 would take 6 minutes, right? And now if I said to you, how fast would it fill up if both of them were working at the same time? Well, if pump 1 is filling the tank in 12 minutes, it's filling 1/12 of the tank per minute. And tank 2 is, I got these reversed, don't I? This is 6. It's the faster tank, 1.
Correct.
Slower tank, twice as slow. It's going to take 12. So tank 1 fills up 1/6 of the tank per minute. Tank 2 fills up 1/12 of the tank per minute. So in 1 minute's time, we fill up 1/6 plus 1/12 of the tank. Well, what is that? That's 1/4 of the tank, right?
Mm-hmm.
In other words, 1/6 is 2/12 plus 1/12 is 3/12
reduces to
We're
1.
going to fill up 1/4 of the tank every minute. So how many minutes would it take to fill the tank? We're filling up 1/4 of the entire tank in 1 minute.
It would take 4 minutes then.
Correct. Okay.
Couldn't we, from just hearing the problem that says one pump fills a tank 2 times as fast as another pump?
Right.
Couldn't we just from there know that the answer is going to be half of the longest taking one?
Let's use variables instead of let's use variables. It's going to fill up the tank in X minutes. This one's going to fill up the tank in 2X minutes, right?
Mm-hmm.
And now let's carry it forth, and we know it's harder to do when you know the sum is 8 minutes. Let me think for a moment. If that fills it up in X minutes, then it fills up 1/X per minute. This fills up 1/2X per minute. And we know that 1/X plus 1/2X is how much of the tank it fills up. Well, that's 2/2X. So that's 3/2X. So it fills up that much of the tank per minute. And it took 8 minutes to fill up the tank, so we have 3/2X times 8 minutes, which is 24/2X, 12/X, 12 is the answer. The whole tank would take 12 minutes. Not explaining this very well, but let's work backwards just so you can see how they should have given it to you in the first place, just because it's an easier problem if we look at it from the other way around. If it takes 12 minutes and 24 minutes, right?
Mm-hmm.
That's what I'm saying the answer is that it takes the faster tank alone 12 minutes to fill up the whole tank. That means it fills up 1/12 of the tank per minute. And this is the way I do all my word problems, is I always bring it down to how much work the tank number 1 is doing on a per minute basis. Well, every minute it's filling up 1/12 of the tank, because it takes 12 minutes to fill up the whole tank.
Mm-hmm.
This one over here fills up 1/24 of the tank per minute. So if they're both working, what part of the tank do they fill up? 2/24 plus 1/24, 3/24. They fill up 1/8 of the tank per minute, working together. Which means it would take 8 minutes to fill up the whole tank.
Right. But
it was the way they gave you the problem. They gave you the 8 minutes to start with, and we have to figure out what this number is. Well, I got to that number doing it the other way, and now I'm checking to see if it's the correct answer, and it is. Based on this logic, the best logic to view this in, and I know they give you a formula that looks something like 1/t⁻1 plus 1/t⁻2 equals 1/r, something like that. Does that look familiar?
No, I've never seen that actually.
Well, that's complicated. That's the complicated way to do it. I don't like that method. But this
Well,
method here works really, really well when you're going in one direction. Notice how easy it was. If I had the 12 minutes and the 24 minutes, I was going to come up with the 8 minutes easily.
but they didn't give you those variables.
Well, so we're going to work it in backwards.
But wouldn't it be easier just to define the variables, such as we can say x is the first pump, and we know x, it fills up 2 times faster than, let's say, z, or y, pump y is 2.
That's why I did it this way the second time. In other words, however long it takes the pump 1 to fill the tank, it's x minutes, and pump 2 is going to take 2x minutes, right?
Right.
Okay, so let's start there. Okay, and now let's go through exactly the same process. That means pump 1 can fill up 1 over x per minute. Right? See how I get that? In other words, when that was 12, I knew that it would fill up 1/12 per minute. This is x minutes to fill up the entire tank. Why do I take it down to a per minute basis? You'll see here in a second.
I get the per minute part, but okay, I get it now.
Okay, now this one is 1 over 2x per minute. So let's figure out, working together, what do they do? Well, this is 2 over 2x. This is 1 over 2x. They fill up, when they're working together, they fill up 3 over 2x per minute. They have told me that it takes 8 minutes to fill the whole tank. So if I multiply that by 8,
it has to equal 8 though, right? Wouldn't it be just some number x times 3 over 2 equals 8?
Yes. I think you're right. It's 20. Yeah, you're absolutely right. It fills up 3 over 2x per minute. I know it takes 8 minutes to fill the whole tank. So the whole tank has to be 24 over 2x, does it not? That equals 1. In other words, 24, I take how much it filled up, working together, it fills up 3 over 2x per minute. But I know it took 8 minutes, both of them working together, to fill the whole tank. So I'm going to multiply this by 8. So to fill the whole tank, it's 24 over 2x, and that equals 1. That's the whole tank, is 1. Now, when I solve for x, I get 12, which we know to be the correct answer.
Right. Now that we kind of define the variables much easier now.
Well, the leap of faith here is coming up with that 1. In other words, this 1 represents the entire tank. 24 over 2x represents the entire rate. That it would, in other words, if it's filling up 3 over 2x per minute, then it's filling up 24 over 2x per 8 minutes. Right?
Well, wouldn't it be...
The problem told us that it took 8 minutes for both tanks to be filled working together.
Right.
So, if they're filling up 3 over 2x per minute, then I multiply that by 8 minutes. So I get 24 over 2x equals a full tank. And that's where I get the 1 from.
Okay.
And then I just solve for x, and I get x equal 12. And we know 12 is correct because we worked it in reverse also. But to work it backwards like this, I think this is the best way to do it. And then multiply by 8, because remember 3 over 2x is how much of the tank they do per minute. So I could actually say that 3 over 2x equals 1/8 of the tank, right?
Right, and that'd be a minute.
Well, if I solve that, I get x of 12. Notice that if I cross multiply here, I get 24 equal 2x. In fact, that's all I have to do. I don't have to go through this 8 times 3 over 2x. I can just say that 3 over 2x equals 1/8 of the tank. Because we know that 3 over 2x is how much it fills up of the tank per minute. And we know it took 8 minutes. So if it took 8 minutes to fill it up, then it filled up 1/8 of the tank in that amount of time. 3 over 2x. Now we can solve. Just, in other words, the moment we come up with this equation here, we're done. We've solved for x.
Then it's pretty straightforward from that part.
Yeah, then
it's setting up
the
equation to find the answer.
Have a simple equation to solve. Anytime you can get your answer set up as one equation with one variable, you're done. In other words, presuming you know how to solve all of those equations. But at this point, you should be able to solve a single equation with one variable, no matter how complicated it is.
Right.
And that's all we did here, is we set up an equation with one variable only. Still a hard word problem. These are called work problems. Very, very similar. You know, you don't see them much anymore. I haven't seen a work problem in 4 years from a student. And I'm not sure why. Yeah, they used to be on all the tests, but they've taken them off the tests. You no longer find work problems on the ACT or the SAT. But the secret, and work problems tend to confuse the mind more than any other word problems will. And part of the secret for doing work problems is to find out how much work is done on a unit basis, whether it's a minute, a second, an hour, depending on what they're giving you. They gave us the problem in minutes. So let's find out how much work is done by machine 1 in 1 minute. Same with machine 2. Adding those two numbers together gives us how much work is done with them working in combination in 1 minute. And it's 3 over 2x. That's how much they're going to do per minute. Well, we know that they fill up 1/8 of the tank per minute. So 3 over 2x equals 1/8.
In the future, would there be complications with using time as a variable?
No. Time is a factor in all of these work problems. In fact, it's a critical variable. A work problem is, by definition, going to have time involved in it. And that's why I said that there is a more sophisticated formula that looks something like 1 over the time it takes one plus 1 over the time it takes the second one equals 1 over the rate. Well, let's see if that's true. We had 12 minutes, so is 1/12 plus 1/24, is that equal to 1/8? Because they told us that it took 8 minutes, the rate to fill up when they're both working. And yes, it is. 1/12 plus 1/24 is equal to 1/8. So this is the right equation, and you could use that equation right off the get-go, only it's not quite that simple. In other words, the only thing they gave us was the 1/8. So now we have 1 over t sub 1, but instead of t sub 2, I'm going to write 2t sub 1. Right? Because they have told us that this one works twice as fast as this one. And now based on this formula, I can easily solve for t sub 1. It will come out to be 12. So technically, we're supposed to use this formula. I always found that formula a little too complicated to work with, and I found that the work problems go a lot easier if you take it down. Say you have two people painting a house. Okay, the boy can paint the house in 3 hours, the girl can paint the house in 4 hours, working by herself. Let's just do another problem like that. So the boy's rate is 1 over 3. The girl's rate is 1 over 4, and that has to equal the rate when they're both working at the same time. Well, that's 7/12 equals 1 over r, so r must be 12/7. So working together, they would take 12/7 of an hour, which is slightly less than 2 hours, which makes sense. In other words, if I solve this for r, I get r equal 12/7, which means working together, they're going to do it in 12/7 hours.
Does it matter if that's an improper fraction?
No,
I mean,
not at all. No, no. In fact, improper fractions are a whole lot easier to work with than proper fractions. And the higher up you go in math, the truer that is. You rarely want to convert an improper fraction to a proper fraction unless the teacher specifically says, put your answer in a proper fraction.
But let's say that it takes an hour for each of them to, or I guess I can't really, I just don't like the way it looks. I'd rather know the exact hours and minutes that it took and do 7 into 12 and get 1, and then that's 5 left over.
5/7 hours, whatever that is, works out to be in hours and minutes.
Yeah. Okay.
That's fine. But notice that in this problem that I made up, these were hours. I didn't go down to the minutes. I left everything in hours. That was the basic unit. Okay.
So it'd be better
now,
to leave it.
I would do this problem. I probably wouldn't use this formula to do the problem. I would say, well, if this guy can paint the house in 3 hours, then he can do 1/3 of the house per hour.
Oh.
And this girl can do 1/4 of the house per hour. Well, working together, how much do they do? Let's say one starts in one corner and the other starts in another corner. They're still going to do 1/3 plus 1/4. So they're going to do 7/12 of the house per hour of working. Well, if you do 7/12 of the house per hour, it's going to take you 12/7 hours to do the house.
Right.
If you did half of the house per hour, it would take you 2 hours. In other words, the length of time it takes is always the reciprocal of that.
Length of time it takes. Okay. I see that now.
But this formula here is actually the one that really, I may start using this formula in the future because it works actually very nicely. And this formula is 1 over the rate that the first person is working plus 1 over the rate that the second person is working, and that's equal to 1 over the rate that they would take working together.
I see that now. I wrote that down. I wouldn't have ever thought of that, using the reciprocal and then finding out the actual time.
That's, to me, a better way of doing it. It's more understandable. It makes more sense. That formula doesn't make any sense when you first look at it, 1 over t. I mean, it doesn't give you any meaning.
Until you plug it in.
Right. It's a true formula, and it works, but conceptually you can't really see it as well as if you do it the way I like to do it, which is to figure out how much each worker can do in a unit of time, whether it's an hour or minute, doesn't matter. But once you figure that out, then you can figure out how much of the house they're going to do every hour.
And that makes it a lot simpler by doing it by the hour rather than by every 3 hours or 4 hours.
Yeah. James, I'm going to have to run. I have a 4:30 also, so
Sounds good.
I don't have any wiggle room on Tuesdays. I got 4 back-to-back. So I will talk to you. I think we have one on Thursday. I'll talk to you on Thursday.
Sounds good.
All right. Bye-bye.
All right.